Hi. This is a solution for homework. For homework 10 and the question 2, and from Hw10. And here we look at those questions first. It told us to find the definition of those 8 statistical processes from professor's lecture notes, and I have found those statistical process, and I noted there where to find them as a number. And first we look at the wide sense stationary process, and its definition is like a statistical process. It's called wide sense stationary process if its mean value is a constant and its R function is only decided by the time interval. It is very easily to understand if a process it doesn't its correlation it doesn't influence between the different time, but only decided by the time interval. It can be seen as some in some sense it can be seen as stationary. That's my understanding. And for the next one, independent increment process, it's from the Poisson process. It's like the two different if two processes their time didn't is non-overlaps, so they should not influence each other. That's my understanding. And for the Mark process, it's like a memoryless system. The next step or the next step or the next probability is only decided by the current step and not related to the steps before the current state. Is like a memoryless system. That's my understanding. And for the normal process, it's like it's also named Gaussian process. It's a very very normal function that you can see many application in the real world, because it reflects a distribution of those things in the real world, like the normal function. And here we should notice that those processes is decided by those four things. That's the thing we want to notice. And for the 5, the strict sense stationary process, it's like it is said that if some process is not affected by a shift of the time axis, it's strict sense stationary process. Compared to the wild sense, it is a more strict assumption. So it makes sense. So that's my understanding. And for the wet nose, it's easy to see that here is decided by this function, and here Q is called the average intensity, and for the next one, the mean ingridic process. For the white noise, it's like it's a very random process. So it can be seen as white noise. And for the mean ingredient process, it's more like to calculate the limitation of some of some process when the t from the very beginning to the very last in the future, it can get a final result. It's like in the mean square root sense, like this function shows, and that's my understanding. That it is not influenced by the. It can reflect all the time from the past to the future. And for the last one, the martingale's process is very funny. It's like its current state expectation is decided by the previous status status previous status arrangements. Like it is it can reflect a very 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 stable state. It can reflect very stable state. From each beginning, you start again, and you have the mean value of your current state, and then you begin to develop, and again, but you are restricted by these things. It's my understanding. It's like those things are control those ones. So that's why it names Marticus. That's my understanding.